Hey, what is good, everybody? Welcome back to the channel. Now, in today's video, we're gonna basically implement a way for us to basically load dynamic libraries. So we're gonna basically extend our platform layer because I want this to be on the platform layer level so that we can essentially load in dynamic libraries. I'm on macOS, so our dynamic libraries in this case will be your dylib file, which you can then load at runtime, right? So if you're on Windows, I believe that's a DLL, and then if you're on Linux, I believe that's SO. I could be mistaken, but I think it's an SO file. Yeah, your dynamic library extension. So right, so let's get to that, and let's see how we can do that. So what we want to do for this is we want to go down to our platform.h file, and then in here, this is where we basically gonna add support for loading dynamic libraries. So just below the window management stuff, I'm gonna put in a comment here, and then I'm gonna just say dynamic I'm sorry about that. I'm gonna say dynamic library management, I guess, right? I'm just using this to separate my functions. So for that, we basically gonna need to create a boolean here, and then we're gonna just call this platform dynamic library, dynamic dynamic library load, like so, right? Sorry about that. And then we're gonna need a dynamic library unload, essentially, right? So this one will basically load the dynamic, oh my goodness, dynamic library, and then this one unloads the dynamic library, like so. All right, and then we're gonna want to add another function here, which will then be used to essentially load in the functions from that dynamic library, right? So we're gonna say platform dynamic library, dynamic, like this, library load function. Okay, so this method will be used to load a specific function from that dynamic library, right? So it's pretty self-explanatory. I'm just putting these comments for you guys in case you just get lost at some point, but yeah. So loads a specific function from the dynamic library. So this basically gives us the address, right, of that function somewhere in memory, I guess. Yeah, and then I guess this is pretty it. This is all we need essentially to be able to load dynamic libraries. So I'm just gonna copy these guys, and then I'm gonna go down to my platform, macOS, and then just pretty down. Let's look for everything that has to do with Windows management stuff. So let me just go back to our platform here. Let's see, platform Windows set title bar transparent. So that's what I'm going to be looking for. And that should be right here. Sweet. So I'm going to paste these guys right here, and I'm just going to get rid of these comments. Again, they're pretty self-explanatory, these functions, so I only did that for it so that you guys can actually get the picture, right? So, oops, wrong key. Press there. I want these guys, so we're just gonna set up these guys to basically work, right? But before we do this, let me just do a return. Why is my caps always on? Return true. Then for this one, we're gonna return true. And then for this one, we're just gonna return null for now because there's nothing to return. I'm just stubbing out these functions. We're not really done in here. and yeah, and just because these comments are really not necessary, just did that so you guys can get it. So we can just remove that. I just like clean header files really. So we want to come up here. I'm thinking, where do I want to put this? But we need a way to essentially store the dynamic library and its data along with its functions. So what I'm going to do is I'm going to create a couple of structs that will basically enable us to do that. So I'm going to create a type def struct up here. So I'm going to be a struct, and then I'm going to call this dynamic library. Dynamic library, I guess, right? And then what I'm going to do is I'm going to open this up. Then I'm just going to copy this name, dynamic library, and just going to put it here so that our compiler is happy. And then what we're going to do is our dynamic library, whatever dynamic library we're loading, is going to have a name. So I'm going to create a const char, and then we're going to call that name. And then we're going to create another const char here. And then we're going to basically give it the file name to that dynamic array, dynamic library, right? So this will just be like, you can consider this like, if this was a plugin, for instance, this would have been the plugin's name, and then this would be the path to that plugin file on your system or something like that, right? Yeah, and then we're gonna have a void pointer to basically hold the plugin, the dynamic library data. So I'm just gonna call this data, like so. And then from there, we're just gonna need a way to basically hold a list of functions that belong to this dynamic library. So instead of doing it like this, I guess I can basically just create another type def struct here. And then you're gonna call this, let's do dynamic library function, right? So this will be basically our dynamic array function struct, and it's going to have everything that's related to a function, right? So what does a function have? It has a name, so we're going to need a const char name, and then we're basically going to need the pointer function to that function, right? So how do I want to just, yeah, it's a void basically. So yeah, a void, and then we can just call this pointer function, then so that you know that it's a pointer function. It's a pointer that points to a function. And then from there, we want to basically hold an array of these library functions. So since we don't have a dynamic list or a dynamic array, I guess the way that I'll do this is I'll just create another type def struct here that will act as a container / array for these functions, right? So we're going to do struct, and then I'm going to just say dynamic library function. So let's just say library functions, right? So library functions, like so, and then open this bad boy up and just do that. And then inside of here, we're gonna basically have this, right? So just paste this in here, and I'm gonna call this functions because it's gonna hold a list of functions, and I'm gonna make this a pointer because it's gonna be a list of functions. And then from here, I'm also gonna need to store some data about this array, right? We're gonna need to know how many elements are actually in this array. So for that, I'm just gonna do a UIN32. I kind of forgot, I haven't worked on this in a long time. Oh, we do have our custom shorthand values for these. So I'm just gonna say this will be then a U32, I guess. So I'm just gonna say U32 instead of a UIN32. It's the same thing, it's just the shorthand version of this. So it's gonna be a U32, and it's gonna hold the number of elements in this array of functions. And then we're gonna need another U32, a U32, and we're gonna call this capacity because this array can have a capacity of, let's say, 4, and then only have like 2 elements within that capacity, meaning we have 2 empty spaces, right, to still add and 2 extra functions. So that's what the capacity essentially means in this scenario, right? Yeah, so now that we have a struct to hold to act as like an array type of thing, all I'm going to do is I'm going to say library functions, which is this struct right here. And then what I'm going to do is, because when we load up this dynamic array, we explicitly have to fetch the functions that we want, aka register the functions at runtime. So I'm just going to call this list of arrays, a list of functions registered like this, right? So registered, hopefully I spelled that right. So registered like so, right? So all the functions that we register will be in this registered list. Well, it's a struct, but it has a list of functions in there, right? You'll see why I named it this way. Yeah, so let's continue. Now that we have the structs that we need, dynamic library function, dynamic library functions, and then dynamic library itself, this is all you actually need. These ones are just sort of like for me to just have things looking pretty nice and organized within the main struct here. So yeah. So all I need to do now is just get some arguments in here. So what do we want to do? So when we basically load in a dynamic library, we basically just want to basically have a name for that library, right? So we can, this will be the internal name for it, I guess, in our engine. And then we also want to basically have what is this, the how do I want to do this? Actually, the way that we're going to do this is we're just going to pass in the name of the dynamic library that we want to load. What I mean by that, let's just say you have a library called, or let's say we wanted to load the Vulkan library, for instance, right? So the Vulkan library is probably saved something like this, I guess, dylib, etc., right? So what we want to do is we want to remove this and then remove this, and then we just want to pass in the name like so, right? So then this will be what you'll be passing in when you want to load the Vulkan library. So you're just going to say load platform dynamic library load, then you're just going to pass in Vulkan, and then what's going to happen is we're going to automatically append the lib and then the prefix, and then append the extension here as well for you automatically. Okay, so that is what I mean by this. Okay, so that will be the name of the library. In this case, you just pass in Vulkan instead of having to type in lib Vulkan like so. That's just tedious, right? So given that, let's just see the struct up here again. It needs a name, and then we need I guess that's it really. All we need to do is just fill in this dynamic library struct, right? So to do that, I'm just gonna say dynamic library like so, and then we're gonna pass in a dynamic library to basically fill out. So we're gonna call this out library like so, and then that's about it. That's all we need to do to load a dynamic library. Just pass in the name and the struct to fill out for you. And then we need to basically have the ability to load a function. So we're going to say dynamic library load function. And then what we want to pass in, we basically just want to pass in the name of the function that we want to load. So we can just say name, and then the dynamic library in which that function belongs to. So I'm just going to take this here and paste it in here, and then it's going to be a pointer, and then we're just going to say the library that we're fetching that pointer from. And then to unload, all you're really doing here is just unloading the dynamic library. So we're just going to pass in that library there, and we're also going to pass it in as a pointer. My spelling plugin library like so. Right. Yeah, and this is how it works. So this will be it. And I realized that I already copied these before. Sorry about that. So let's just go back to here, because I realized that I already copied this. So I'm just gonna do this, and I'm just gonna get rid of this. Sorry about that for those who are actually following along. step by step. But yeah, we made mistakes, right? So sorry about that. So I'm going to save all of this, and I'm going to get a bunch of errors from Xcode, which is fine. So we need to step out the way to load a library. So how do we want to load a library? This is fairly very simple, especially if you're on macOS or Linux, because it's pretty easy to do. Okay, so we're going to need a couple of things. So we're going to need a header file. So I'm going to come all the way up here. I'm going to say import, and I'm going to import dlfcn. This is what we use to load dynamic libraries on post Unix processes, operating systems, or whatever, right? So if I just go into this file, it's basically all you need to basically load in your DL dynamic libraries, right? So you can see the DL, I assume, basically just stands for dynamic library, and then you can just read through some of this to see what it is that we want, right? So yeah, anyway, let's get back down there where we need to be. So that is here, platform dynamic library load. So what I want to do now is just stub up this function. So we are going to check if this dynamic library struct has been passed through. If not, then we're not going to basically load anything because there's nothing to load to, right? So we're going to do a sanity check. So we're going to say if out library does not exist, and then we're just going to return false and not do anything. Then we're going to check another thing as well. We're going to check if the name, right, is not passed in as well. Essentially, we are just going to return false because we need a name for our dynamic library, isn't it? So I could just condense this into one check, I guess, because we are checking if the out library or the name is not basically in there. So yeah, let's do that. I guess we can just move all of this in here. So if either the name or the dynamic library is not passed through, then we just boot out. So I guess I can just reorganize this to basically match the order that we're passing in these variables in, and we can just remove this. Okay, right. But if this condition, if we've passed in the name and the library, then we can essentially do a memset. We want to basically zero out the dynamic library struct here that we passed in. Okay, so I'm gonna just say out library like this. I'm just gonna set everything to 0. So I'm just gonna get the size of the out dynamic library like so. Okay, and that is perfectly fine. All right, so now that we got that, we need to basically see. So we have set the out library to 0. Now we need to basically have a way to fetch or to load the dynamic library, right? Now that we have a name. So because I wanted this to be like this, because we know that a library has a lib prefix, and then the name of the library, which is Vulkan in this instance, and then we have the extension. On Mac is dylib. I think on Linux is an SO, and then I think on Windows is a DLL. So what we want to do is the extension, we basically want to put that automatically, and along with the DLL here, the extension, we want to append that dynamically, automatically for the user of this API, along with the prefix, right? So we are going to create a let me just comment this out just so that we can keep that as reference. So we want to create a char called file name, and then I don't know how long dynamic libraries namings can go, so we're just gonna stick with, I don't know, 256 characters. Okay, for now, I guess. Yeah, and then we're gonna basically zero out this array. So we're gonna say memset, and then I'm gonna say file name. Then we basically gonna zero out that memory, and then we're gonna say size of this is a char, and then the number of characters we have in there are 256. Okay, like so. And then all we want to do now is essentially have a const char. This will hold the extension for us. Extension const char extension. And for now, because we don't really have a way to detect what platform we're on, well, we actually are already on a Mac, and we actually filling this up on a Mac platform. I guess we could just simply say dot dylib. Yeah. And then for the prefix, that will just be lib, like this. And then we just need to rename this to prefix. Okay, so I guess we could reorganize this like this, because you're gonna add this, then we add this, okay, to the file name, because we're only gonna be passing in the name of the library itself, which is in this case Vulkan, to be exact. But we're not really gonna load Vulkan dynamically in the beginning, but yeah, just know that it's possible. Right, and then the other thing that we want to do now is essentially have a const char, and I'm gonna call this library. Okay, and I forgot the pointer here, and then this will be the name of the library. So we're just going to append this guy and this guy to the name. Okay, so to do that, we need a function to basically string format this whole thing to the what we want it to be, right? We want a string format function. We want a string format function, I mean, to basically enable us to append these guys to a string. Now C, I believe, has, I don't know if it really does have, but we will basically make our own. Okay, so we're gonna take a detour here. Just gonna close this up and comment this out, and take a little detour. So in our core, do I want to put it in core? I guess we can. So in our core, we are essentially going to create our own string library. Okay, and I'm going to call this, what do I want to call it? Because we're building a graphics engine, I guess we can just call this graphics string. That is not okay. That's too long. G string? A G string. Sounds very wrong. Sounds really wrong. I can't go with C string because that already is taken. You know what? I'm gonna risk it, and we're just gonna call it a G string. The G stands for graphics, by the way, so don't come for me. All right, and oh, this will create the header file for us, so that's fine. And then we're basically gonna have that guy here. So this will be our custom string library. Yeah, so let's do that. So inside string.h, I'm avoiding that. Yeah, so inside of this, we are basically going to have two functions that we want to add for this, to basically enable ourselves to essentially be able to format a string the way that we want it to be formatted, right? So we're going to say void. Well, actually, it's not a void, so let's do a const char like so, and then we're going to name this string format. Okay, and I'm gonna append this with a V here, and then this will be like so, and then we're just gonna have one like so. Okay, and then do I really want the other one to be, yeah, okay, yeah, it's fine. So I'm gonna copy this, and then I'm gonna come in here. Then we're gonna basically implement this, and again, I did the same mistake that I did before, so let's go back. Sorry again. And actually filled in the arguments here. So for this one, essentially, it's going to take in the VA list. So that's what that V stands for. So it's going to be const char format. So, and then you're going to have the void pointer to the VA. list, and it's just gonna call it a via list pointer. And then the second one, essentially the only thing that it takes is pretty much the const char format, and then we just want to pass in the arguments, how many arguments we want. So this function, we will not call it directly because it will be called within this function. So you'll see what I mean. Okay. Yeah. And then we're gonna come inside here, and we're just gonna fill in these functions. So I probably might fast forward this because it's not part of the scope of this video. So yeah, I guess I'll fast forward. So this is our custom string header, custom string library, I guess. It's not really a library, but it's internal to the engine. So this function right here enables us to basically format string to however we want, right? So I'll show you this in action. So let's go back down to what is this? Our platform. So this is where we were. Okay, so back here we can uncomment this out, and then all we can do is say string. Well, actually we need to import this, so let's go up here, and I'm just gonna copy this, and I'm just gonna say G string. So that's our graphics string for our library, for our graphics engine, I mean. So yeah, it still gets me, but anyway, yeah, fine. So we can say string format like so, and then all we want to do essentially is pass in the string that we want to format. So we can do this. So we can say this will be a string, this will be a string, this will be a string. Okay, and then what we'll have is we'll have the prefix first, then we're gonna have the name first, and then we're gonna have the extension last, like so. Okay, what this will give us is essentially this. Okay, it will take the name that we're passing in here and then squeeze it in between this and this. Okay, so that you don't have to pass in this and this explicitly within the name. Okay, makes sense? Hopefully that makes sense. Okay, so let's move on now. Now that we have the library name, let's go ahead and basically load this. Okay, so let's do a void pointer, and let's see, platform dynamic library load. So we got here void pointer. So what we want to do is basically make use of that DL open situation. So how do I do this? Let me just say dynamic library equals to DL open like so. Then we're just gonna give it library, which is this guy here. So we're gonna pass in that into here. Then the mode that we want to open this in, I'm just gonna go with RTLD now, and then leave it like so. Okay, then this will then open that dynamic library for us, and then we're gonna check if that was successful or not. So if dynamic library does not exist, then we're just gonna say printf, and then we're gonna say error loading dynamic library, and then we're just gonna do an S here and probably another S here just so we can have proper error messages. So one will give us the library that we want to load, and then the other one will be the error that is passed through by the DL open function here in case it failed to load it. Okay, so yeah, and then I'm just gonna add an extra line character there and then return false here like this. Okay, so that's good. So but in a case that the library did indeed get loaded up, all we want to do is we want to fill out this struct. So all we're going to do now is just say out library, right? And then we're going to say name equals to the name that we passed through in, and then we're going to say file name is going to be the new file name that we basically created there, so which will be file name, like so. Actually, I'm thinking that I made a mistake somewhere. Hold on. Let me see. File name. Am I even using this? I'm not, because actually I'm not. So we don't actually need to. I'm sorry. I'm so used to the old way that I did this before, because I know before I did it that way, but then I forgot that I sort of kind of changed the API a little bit. So we actually don't need that. Yeah, because the file name is now library, right? Hopefully that makes sense. Yeah, hopefully that makes sense. And then we're gonna say out library, and then we're gonna say data is now equals to, actually, hold on, file name is the library. So, and then the data is going to be our dynamic library. Oh, yeah, my naming is trash. So let's do library name so that we are consistent with our namings here. So this will be a library name, and then this will be the data itself will be the dynamic library, and then here we're just gonna pass in the library name. Yeah, so now it's a less confusing than it was before. And then all we want to do now is just allocate some memory for our function list. So we're gonna check through the registered functions, and then we basically just gonna take this functions list array whatever, and then just malloc it so that at least it has initial memory in it, so that it's not null. So the way I'm gonna do this is just gonna say size of the dynamic library. Let me go back here for a minute. Let's see what I call this. Library functions. I called it library functions. So size of the library functions struct, and that's about it. Okay, and then down here, all we can then do is just, because this basically allocates memory within this, all I'm gonna do is I am just going to free that. So I'm just gonna say free library name, passing constructs, a parameter of type void, discards qualifier. So I can just cast this to a void pointer. I mean, it's fine. And then we return true. Okay, so this is how we load our library. And again, if you are on Linux, you'll just replace the extension with .so, and if you're on Windows, then you'll just replace this with a .dll situationship. Because this is a platform macOS layer, I'm just doing it explicitly like this. But if you guys were implementing or following along from a different platform and you found a way to essentially create a platform layer for that specific platform, then just keep in mind that you'll just have to change the DIY to basically suit whatever platform you're on. And again, this DL open and yeah, DL errors and stuff. These work on macOS and Linux, but I do know on Windows you'll have to use the Windows specific API for that. H module and all of that stuff. I don't know. I don't remember, but yeah, just keep that in mind. So just research a way to do that on Windows, and you should be fine. All right. So now let's go fill out the struct, the function here to basically load a function. Now that we have loaded the library, so this one should essentially be hopefully easy. So let's do a sanity check here. Load function. So what I'm gonna do is I'm gonna check if we pass in the name and if we also passed in the library itself. So library like so. And then if not, then we basically gonna return null because this returns a void pointer. So it should be returning the function, but in this case, because you didn't pass in the name nor the function to store that function, nor the library to store that function in, we can't do anything really. So just return. And then we're going to do another sanity check here, and we're simply just going to check if the library basically has data. Okay. And then if it doesn't, we're just going to return null as well here. Okay, and then all we're gonna do now is essentially just going to get the library that we want. So we're gonna create a void pointer here, and I'm just gonna call this function address because essentially we're just getting the address or the function that we want from the dynamic library. And then all we want to do is just say DLM symbol is going to give us that. So we're just going to give it the handle, and the handle of our dynamic array essentially is where is it? Oh, it's in library.data. Okay, that's why we checked if this exists. Okay, and then all we're going to do is basically give it the name of the symbol that we want. So that's that. Okay, and then once we have that, we want to check if indeed it's there. So we're gonna say func address is indeed found. So then we're gonna return no. Now you could do a print here, like printf couldn't find function in library or something like that. You know, you could do that. I guess, right? If you wanted to, like so. You could say couldn't find function in library, but I'm gonna check this on the other side where I'm actually loading the function itself. So I'm just gonna return null and then check if I've returned null or not on the other end where I'm using this API. But you could do that there as well if you wanted to. So yeah, and then if the function was found indeed, all we want to do now is just say dynamic library function, and I'm just gonna say func here equals to just zero everything there, and then all I'm gonna do is I'm gonna say func dot name. I'm gonna set the function name to the name that we passed through here, and then we're gonna say func dot pointer function is is the function address. Okay, something like that. And then once we're done there, all we want to do is essentially save this to the list of functions that this dynamic array has currently registered. Okay, so to do that, I'm going to say library dot registered. We want to find the list of registered functions, and then inside of there we essentially just gonna want to index at library slash registered dot count. Okay, we want that index, and then we want to basically set the function to func yeah, like so. Okay, and then all we want to do next is just say library dash library dash, where is it? oh, I think it's in here, dot count, that we just basically increase that count. And then because we need to return something, we're going to return that function address here. Okay, so what is happening here? So what is happening is we're loading the function from the dynamic array. We're getting the function address of that from this function, which is from, if you just open this up, it's inside the dlfncn, the one that we included in our implementation file here above. So it gets that, and then we check if indeed it found the function, and if so, we're then doing some internal stuff to essentially take that function and then store it within a dynamic library function struct, and then take this struct and then store that struct within the registered functions list / array of functions. And then that's what we're doing here, and then we're incrementing the number of registered functions that we currently have, right? But now I'm noticing something. Yes, we allocated memory for this list, so probably it has a memory for this guy, but it won't have memory for the next function that we want to register or something like that, right? So we want to do the same trick that we did for our event system. So I'm going to open up my event system here real quick, because we have a function, a method that we use to essentially resize an array. So I'm just going to copy this and come back to our platform layer here, and I'm going to paste this inside. I'm just going to make this static because it's literally just static, and it should only be public to this function itself. So we're going to need to basically rename some stuff here. If you've been following along with the series, you'll know that we created this function when we were building our event system there, because we are not using a dynamic array. So we basically will have to do all of this allocation and resizing and everything manually for now. But in the future, we will replace all of this with a dynamic array. It's just that I don't want to do that right now, and I just want to show people how to do it manually. So yeah, so the first thing that we want to change here will essentially be where this list is actually contained in. So it's contained in library functions. So I'm gonna basically say library functions, and then this will basically, we'll call this list, I guess. And then size, new capacity equals to list dot capacity list dot, wait, hold on, wait, what? Yeah, oh yeah, it's fine. List capacity. I thought I was duplicating myself there, but it's okay. And then here, instead of subscribed event, it's just going to be a dynamic library function, like so. And then instead of new events, this just will give us a new list of functions. And probably might want to make this a pointer now. And then do we still reallocate? Yes, we still do reallocate, and I'm just gonna rename this to list, and instead of events, it's gonna be list functions, and then we're gonna say new capacity times dynamic library function. And I think that's what we will do there, and then we're gonna check if this was successful. So we're gonna do this. And then what do I want to do? Then down here, we just want to replace this with list, and instead of events, it will be functions, and then instead of new events, it will be new functions. So essentially, that will just resize our function list. So function array, I mean. So we're gonna say function resize functions array, like so. And then list capacity, it says what? Implicit conversion loses integer position size t. What is the data structure for this? Is a U32. I guess. You know what? Maybe, I don't know, which is better? Like, tell me in the comment sections below, size T or U32. which is better, guys? Just tell me. I don't know. I don't know. I'm not too technical in terms of memory and efficiency, and I do know sometimes this is not good, especially when we're gonna be when we're gonna end up doing this quite a lot. So, but for now, it's just a hack. Like I said before, we will have a custom dynamic array that will handle all of this dynamically, and instead of just doubling this based on the size, we're gonna basically allocate way more memory than we need, and then traverse and add stuff to it and remove stuff to it, etc, etc, right? But for now, this is just a hack to get things working. And yeah, so right before we add any of this, actually, that's where you actually want to check if we actually do have capacity for that. Okay, so to do that, we're just gonna say library. So we're gonna say library registered. We're gonna check if the number of registered elements inside there is actually greater than the capacity, what we can actually hold. So that would be library registered dot capacity. If it's greater than the capacity, then for sure we want to, if it's greater or equals to, we for sure want to resize the array, right? So we're gonna do so by just calling the resize function. So resize functions array, and then we're going to pass in the array that we want to resize, and that will be stored in the library slash registered struct there. So that's that, and then we're going to return null here. We resize, and I think that's fine. And then from there, we do this. Okay, sweet. Yeah, sweet. What else do we need in here? I guess that's fine. So then we need a way to unload the library. So this should be pretty simple. Essentially, I'm going to do the same sanity check that I have up here. So I'm just going to copy this, and then in here, and then the only thing I'm going to get rid of is that name, because we're no longer passing in the name. And then we're going to check if it has data or not. So instead of returning null now, we just need to return false. And we're going to return false here as well. And then we actually want to get we want to get the result from this function. So dl close, and the handle of the library that we want to close is actually just stored in data here. And then I think we just want to basically check if this was successful or not. Okay, so if the result is not equals to 0, then return false, because if it's not equals to 0, meaning that it's not successful in this case, we just want to return false. And I'm not sure if the success codes differ from operating system to operating system, but I think they do. So I think on Windows it could be something else, but in our case here, 0 it means success. Okay, this could be different in different platforms, Linux or Windows, I don't know, but just keep that in mind. If not, then I guess it's fine. Yeah, okay, so then we're gonna say what am I, yeah, there we go. Then we're gonna say data, just set that to 0, and then from there we just want to essentially free our functions array to deallocate that memory so that we don't leak any memory. So we're gonna say, well, I keep referring as library as a plugin. I guess you can consider it as one. I just got used to loading plugins in the other engine, but anyway, it's fine. Library registered the functions, and if there is a list of functions in there, we just want to free that list. So again, library registered functions. So we just want to free that list of functions, and then we just gonna set the list to 0 now. So let's just do registered functions, set the list of registered functions to 0, and then from there we're done. And then we just want to do a mem set here, and we're just gonna set the library struct to 0 because we unloaded it. So we just make sure that we do a proper cleanup everywhere. So yeah, dynamic size. Oh, this should be size of. That's why I wasn't getting the IntelliSense there. Dynamic library. Okay, and then once all of this is successful, we just return true, and that's about it, ladies and gentlemen. So we have the ability to now load and unload dynamic libraries, and then load specific functions from that dynamic library for us to use in our engine. So this is it. I guess I'll leave it here for this video. We could test this, but I don't have a dynamic library to test this with, unfortunately, at this moment in time, but we will definitely test it in future. Or actually, what I could do is, the reason why I'm coding so well on my videos sometimes is because before I actually create a video, what is VS Code? I actually code this out myself, isolated in isolation essentially. So I just want to show you that, don't save, that I actually do, where is it? So let's do plugin system. Yeah, here it is. So the reason why I most of the time just prefer to code things from my head, or it seems that I'm efficient in what I'm doing, is because before I record these videos, I actually just go ahead and do a practice run on my own, and then just sort of like try and remember what I did, etc, etc. So this is essentially what we coded, but it's isolated. So it's called a plugin system here because we don't have a platform layer or anything like that. But if you look at this closely, it's what we just coded up in Xcode. And actually here I can actually test it for you guys so you guys can see what's actually happening. So I guess we can do that. So let me just give you a brief tour of what's actually happening in our project folder here. So what we have is we have an app folder. This is what contains our main.c file. You can maybe consider this as your game or engine or whatever. And then you're gonna have a plugins folder, which you'll then have plugins for your game, engine, or whatever. In this case, we have a plugin for a renderer because we can actually have different types of renderer. We can have a Vulkan renderer, we can have a Metal renderer, and I want to treat them as plugins to our engine or whatever, right? So the plugin folder basically holds all the plugins, right? And then the renderer itself is a plugin itself. So in our make file, what's happening is we have a command to basically build the engine itself, or the client. Let me just say client maybe, and then we have a command to basically build the plugins. Okay, since we only have one plugin, it's just gonna build that one plugin, and then yeah, and then basically make sure that it is a dynamic library, and then basically just store that as a dylib because I'm on macOS. And then from there, inside here, when we basically want to load that dynamic library, because we have the app and the dynamic library next to each other, so we can basically say, hey, I want to load this dynamic library at runtime. So this is how we would do it at runtime. So we'd have plugin load. This will be platform dynamic library load, and then giving in the library name. And this is how we basically passing in the name of the library. So in this case, it says renderer plugin. But if you look here, it's actually lib renderer plugin.dylib. You see that? But for us, we only just want to pass in the name. That's what we did. This is what we did here. Where is it? Where is it? Where is it? Where is it? This is what we did here with this whole situation. Okay, so yeah, and then from there we can load in the different functions that we want. So our library has these functions that we basically can load up in the main.c file. So it has render, draw, update, resize, and begin and end, and therefore we just calling those, we're just loading them up, and then we basically assigning them in here because we have a struct here a plugin struct. In this case, it's a renderer plugin, and then it has pointer functions, basically to draw, update, resize, and begin. And then we're just populating that with the functions we just loaded from our library. So if we just run this, so if I just go to cd bin and then I just run this app, you'll notice that when I run it, this is just debug info, but when I run it, I'm calling renderer.draw. So it says render is drawing, render.update, render is updating, render.resize, render is resizing, render begin and end. So it's basically fetching these from the dynamic library, and the implementation of that is just a simple printf statement for each, and then we just calling that within the main.c file, right? So we've loaded that as a dynamic library, and then we basically populate our pointer functions for our plugin to essentially point to those functions, and then we can call those functions at runtime and reload them. And this opens many doors, such as enabling us to actually create a hot reloading feature, which I'll also show how to do, by the way. But we're not at that level. I could just pretty much code one from scratch right now at that, but I actually want to do it properly. Yeah, this is how it works. And you notice how I'm doing this way. You have to keep track of the order that you're basically loading your functions in. But if you don't want to do it this way, then you do know that you do have an array where these functions are actually stored, so you can always refer to them as you want. But if you don't want to populate this pointer functions this way, all you could do is just do this, because when you load the function, you're also returning the function that you just loaded. So this right here could still work, right? You don't have to do it. You have two ways of doing it. So this is just one way and this is the other way. So it's just up to you how you want to do it. And then just copy this one over here like so. Wait, what? Just copy this one and paste it in here, and you could just theoretically just get rid of this. So you load your library and then you load the functions, populate your pointer functions up here, and then from there just run your application. And once you're done, in the end, you just unload the plugin, dynamic library in this case, and you're done. And that's how it works. And then this count, it was just me testing to see if my resize function is actually working appropriately, and that we are actually allocating memory, and we are only allocating just about enough memory that we need. So it's just coming from this printf statement, so we can just get rid of that. But yeah, so this is what I do before I record my videos. I just sort of do it, and then I try to do it from my head when I'm actually recording. That's why sometimes I would forget certain things, but it's just good for your memory practice and all of that stuff. So yeah, so now you've seen that it does work. So in our engine, this will work in a similar way, basically. Yeah, it will work in a similar way. It's just that now it's hooked up to a platform layer. So yeah, that's about it. So ladies and gentlemen, if you enjoyed this video, do definitely hit that like and subscribe button, and I'll see you guys in the next video. And everything else still works as it should, no errors. And yeah, cheers.